Hi, welcome to this lesson on Euclidean geometry, ratios and proportions. Let's have a look at question 3. Consider the trapezium ABCD, shown below. If it's given that the ratio of T is to P is to Q is in the same as 2 is to 3 is to 5, and the area of this trapezium as ABCD is 288 square centimeters, then calculate the values of T, P, and Q. Okay, so first of all, we're going to need some information. So first of all, the area of a trapezium is given as half times the sum of the perpendicular, or not perpendicular, the parallel bases. So in this case, AB plus DC, times the perpendicular height between those two bases. Okay, so the perpendicular height, if you look here, was actually extended outwards and given as T. So I can rewrite this equation as a half times AB was P, DC is Q, times the perpendicular height of T. So we have this equation and it's given to us as 288 square centimeters. So that's a useful equation. So let's jot it down and make sure that we can try and utilize it in the question. We're also given that the proportion of the sides are in this proportion here. T is to P is to Q is 2 is to 3 is to 5. So here we're comparing three quantities. So how we read this, for example, is T is to P is in the ratio of 2 is to 3. P to Q is in the same ratio as 3 is to 5. We can also read it as T to Q is in the ratio 2 is to 5. Okay, so as long as we read it in the correct order, that's what these ratios are saying. So I'm going to jot them down. I'm going to say T divided by P is the same as 2 divided by 3. Okay, so that's one equation. Then I've also got P divided by Q is in the ratio 3 over 5. That's another equation. And I can look at the outside ones, like I said, T over Q, that's equal to 2 over 5. That's another equation. Okay, then every other ratio that we try and look at, like for example Q is to P, that'll be 5 over 3. It's just a reciprocal of equation 2, for example. So I think those are the main ones that we can utilize. So now the goal is to solve for P, Q, and T. So we've got 1, 2, 3 equations in 3 unknowns, which means we can essentially solve for T, P, and Q. And we've also got a fourth equation here to help us work out those values. So we need to think of a clever way of manipulating maybe this area formula here so that we get something resembling one of these ratios here in some form or another. Okay. So the area of the trapezium, okay, so what I'm going to do is I'm going to multiply both sides by 2. So I'm going to get P plus Q times T is equal to 288 times 2. Which is 576. So this implies that if I distribute that out, I get P times T plus Q times T, and that must equal 576. Okay. Now notice that T is common to both. So if we can somehow rewrite P and Q in terms of something in T, then we'll just have an equation, a linear equation in one variable. Because right now we've got 3 variables in one equation, which is not easy to solve. So if we can just reduce it down to equation with one variable, then we can solve for that one variable and then work backwards to solve for the other 2. So this is simultaneous equations. So I need to use these ratios here to try and write P and Q in terms of T. So if I look at equation 1, T divided by P is the same as 2 over 3. If I cross multiply both sides by P, then I get T equals 2/3 P. And then I can try to get P by itself in terms of T. So I'll multiply by 3 and then divide by 2. So P must equal 3 over 2 times T. So that's one equation. So I can substitute that in. So P is 3 over 2T times T plus. So now let's look at equation 3. That's T over Q equals 2 over 5. So we can do a similar thing here. So now I'm going to take the reciprocal on both sides. So if I flip over Q over T, that's the same thing as 5 over 2. And then if I multiply both sides by T, I get Q equals 5 over 2T. Okay, so now I can substitute that in. So it's 5 over 2T times T. Now I've got a equation with just t's. Okay, so I'm going to get 3 over 2 as becomes t squared plus 5 over 2 times t squared equals 576. So because they have the same denominator over 2, I can add them. So 3t squared plus 5t squared, they are common terms, like terms. So I can say that's 8t squared over 2 equals 576. But 8 divided by 2 is 4, so I get 4t squared equals 576. Now I can divide 576 by 4, and I get 144. So therefore t squared equals 144. And then to find t, I would square root both sides and get t equals plus or minus 12. But I'm not going to use negative 12 because look at the context of the question. T is a height, a perpendicular height of a shape. So it doesn't make sense to be negative. So I take positive 12. Now that I've got t equals 12 here, I can go ahead and find p and q because I've got equations that relate p and q in terms of t. So therefore p equals 3 over 2 times t. So 2 goes into 12 6 times. 6 times 3 is 18. Don't forget we were given unit measurements, so I should write here centimeters and centimeters. And then lastly, q was given as 5 over 2 times 12 centimeters. So again, 12 goes into 6 times, so that's 30 centimeters. So P here is 18 centimeters, Q here is 30 centimeters, and the perpendicular height was T, which was 12 centimeters. And you can check it satisfies the original equation, right? A half, so this is the area, the one base 18 plus the other base 30 times the perpendicular height of 12, and that gave us 288 centimeters squared. All right, so those are the correct values here. Okay, so that's how we would do this type of question. I'll see you in the next one.